Today we are going to learn the Fraunhofer diffraction in double slit experiment, which was discussed earlier in our interference class, the Young's double slit experiment. And later took a look on this picture where two slits, each of with A, and are separated by an opaque space with B. So there are some corresponding points between the two slits. Corresponding points means the similar kind of points in the two slits, which are, say, the extreme bottom point of the first slit and the extreme bottom point of the second slit, or the extreme top point of the first slit and the extreme top point of the second slit. They are called the corresponding points, or you can say the middle points of the two slits also, because they are A plus B distance separated, which is denoted here by small d. See, it is written over here, the small d is equal to A plus B. So A means this length and then B, so you will reach this point, and if the distance between two points of the two slits is A plus B, then the 2 points will be called the corresponding points. So the D is the distance between two corresponding points. So let us first understand the coordinate system. Here the origin is taken at the bottom slit, the middle point of the bottom slit O. So the extreme bottom point of that slit will be minus A by 2, and the upper point will be plus A by 2. So the bottom point of the upper slit will be D minus A by 2, and the topmost point will be D plus A by 2. And in this space B, small b, is the opaque space where no radiation will fall, but those radiation will not pass into the right hand region. And the arrangement is similar to the single slit, that is, a lens is there to converge the rays which are diffracted from each slit on the screen to make the diffraction pattern. Let us consider the point P, where we are going to investigate the superposition, the intensity coming out of the superposition of two light waves which are diffracted by an angle theta, one coming from the point O and the other coming from the line element dz, which is z distance above the point O. So the process of determining the resultant intensity at the point on the screen is similar to that of the method described in case of single slit pattern in my previous video. So to just if you forgotten all this thing, just go and learn from that video. Now P0 is the midpoint of the screen, actually the midpoint between the two slits, that is the midpoint of the opaque space B. Okay, no, I should reframe my sentence like this. If you draw a perpendicular on the screen from the midpoint of the opaque space, then it will cut the screen at the point P0. Okay, so P0, from P0 we will going to evaluate the distance or determine the distances of the what you call the fringes. Now start from the length dz. The process is similar. The electric field at the point P due to the line element dz is k into dz into e to the power I into omega t minus 2 pi by lambda into r into e to the power minus e to the I into 2 pi z sin theta by lambda, where z sin theta is the path difference between two rays which are diffracted by an angle theta, and one coming from O and another coming from the element dz. And it is described in my earlier lecture So this is the same as described in the case of single slit diffraction theory. So now we are going to integrate to find the resultant intensity or resultant field first at the point P, because the lights are coming from this slit and then there is a discontinuity and then this slit. So the integration will be minus a by 2 to d plus a by 2, yes, because the lower limit is minus a by 2 and the upper limit is d plus a by 2, but there is a discontinuity. So the integration will be minus a by 2 to plus a by 2 over d and d minus a by 2 to d plus a by 2. D minus a by 2 is the bottom point of the upper slit and d plus a by 2 is the topmost point of the upper slit. So if you follow some procedure, you know this phase part is constant, so it will come out of the integration, because integration is on dz. Again, I have forgotten to write here the differential dz. Here the dz should be written. Just I suggest you to correct this and follow the integration, do the integration, which is nothing but it will call x type integration, mx type integration. So it will follow this result, this results, and here pi a sin theta by lambda, here also pi a, yes, here pi 2 pi d sin theta by lambda will be taken common out of this second bracket and resulting the two same terms. So they are taken common out of the no, first we assume the term pi a sin theta by lambda as alpha and here pi d sin theta by lambda as beta. Okay, we have assumed these terms which will be used in the latter of my lecture. So this will ease your calculation, because this is nothing but sin alpha, this is sin alpha, and it is again sin alpha by alpha like term. Now yes, this is the final expression, where you can see this is the phase part because time is there, and this is the amplitude part. The rest of the part is the amplitude, because those are constant with time and position. So amplitude will it is complex in nature, you can see. So amplitude square or modulus of the amplitude square will be the intensity is proportional to mod of E0 square. So E0 into E0 star will be done to evaluate I. So I should be proportional to, you can easily take the complex conjugate and multiply them. So this will resulting in 2 plus 2 cos 2 beta. So 2 is taken out, so 1 plus cos 2 beta and 2 cos square beta will be the result. So 4 is written in the at the first of the line. So 4 k square is square into sin square alpha by alpha square and cos square beta. You can see that and now use some normalization thing, where if you take theta is equal to 0, where theta is equal to 0, theta is equal to 0 will be formed at this point. Okay, so theta is equal to 0. If you take theta is equal to 0, then what will you get? You will get alpha is equal to 0 surely, because alpha is your pi a sin theta by lambda, so alpha should be 0 here. So alpha is equal to 0 means sin alpha by alpha tends to 1. If you take the limit alpha tends to 0, so it will give you 1. And for the single slit, we know this is the single slit result. See, this is your single slit intensity result, and which is tends to k square plus k square is square at theta is equal to 0 or alpha is equal to 0. So the single slit intensity at theta is equal to 0 is written as I0 say. So I0 is proportional to k square square. This result is well known from our previous class, and we can use, instead of writing this term, not the whole term, this term, in place of this term you will replace I0. So it is written over here 4 I0 sine square alpha by alpha square into cos square beta is your resultant intensity at the point P due to the double slit experiment. Now this is purely single slit term, single slit diffraction term, but the cos square beta, you know, 4 I0 cos square beta is your interference term originating from Young's double slit experiment. You know this, and you just back to look at the theory of double slit interference from Young's experiment. You can exactly find that 4 I0 cos square beta is the intensity of resultant intensity of at any point due to the double slit, where beta is equal to exactly the same pi d sin theta by lambda, where d sin theta is the path difference between the two corresponding points of the slits. And so to find the maxima and minima, we should find the maxima for the diffraction and maximum minima for the diffraction and maximum minima for the interference separately. Okay, so okay, let's do this. Condition for minima: first I will be 0, that is intensity will be 0 to get the minima, to get the dark point at P, if either of the diffraction term or the interference term are 0. See, they are multiplied to each other. Two graphs, one cos square beta graph and one the sin square alpha by alpha square, which we have drawn in our single slit diffraction class. Those two graphs are multiplied to each other. If you want to understand by graphical theory, I will describe it later, but first let's use the simple algebra. Here the two terms are multiplied to each other. So if one of them is 0, then the whole result will be 0. So interference minima or diffraction minima will produce the resultant minima. So the first condition is diffraction minima, that is sin square alpha by alpha square is equal to 0. So alpha is equal to surely your plus minus m pi, where m is not equal to 0 but other integers will be admissible for m, because we know from the single slit theory that if m is equal to 0 then alpha should be 0, and if alpha is equal to 0 then sin square alpha by alpha square is 0 by 0 term to reach you the central maxima of the diffraction pattern. So just assume that alpha is equal to plus minus, not assume, just take the formula as alpha is equal to plus minus m pi, where m is not equal to 0. So it will give you the condition a sin theta is equal to plus minus m lambda, which will be the diffraction minima. We all know this very well, and the interference prime minima for the interference minima, either or condition. So interference minima can happen for cos square beta is equal to 0. So beta is equal to plus minus 2p minus 1 into pi by 2, where p is equal to 1, 2, 3 but not equal to 0 surely. And you can see 2p minus 1 is an odd term, so odd multiple of pi by 2, whether it is plus or minus, will give you cos square beta is equal to 0. So put the value of beta, and from here you can find d sin theta, which is a plus b into sin theta. D is equal to a plus b, we know that, I have shown it earlier. So a plus b sin theta is equal to plus minus 2p minus 1 into lambda by 2 is the condition for interference minima, which is similar to the Young's double slit experiment minima condition. And for the condition of maxima, individually those two maxima should be considered. Now first the maxima for the diffraction, and where again if you consider theta is equal to 0, alpha is equal to 0, you will get the central diffraction maxima. And for the other angles such as alpha is equal to plus minus 1.43 pi or plus minus 2.46 pi or so on, these points will give you the secondary maxima We know this from our previous single slit diffraction class, that those values of alpha were determined from the graphical solution of the equation alpha is equal to tan alpha. So I am not going into this, just using the result of secondary maxima, and you will just approximate that 1.43 is your 3 by 2, 2.46 as your 5 by 2, but it is a crude assumption, not so crude for the higher orders, but in the very beginning it is an assumption which is far away from the exact result. So 2s plus 1 into lambda by 2, it is written because it is easy to remember these terms. 1.43, then 3 by 2 is easy to remember than 1.43, so I have written this, but my suggestion is to remember both the forms, whichever is convenient, you use them. And for interference maxima, you know that cos beta should be plus minus 1, so that cos squared beta is maxima, that is 1. So beta will be plus minus n pi, where n should be 0, 1, 2, 3, any number, any integer value. So it will give you a plus b sin theta is equal to plus minus n lambda. It is a maxima condition for the interference, you know this. Okay, so nothing new conditions we have found, because we are dealing with the interference and the diffraction is very independent manner, but both of them can happen at the same time. There is no harm to take place the two maxima at the same time. Well, it is good for the maxima, say central maxima or the maxima condition, but what will happen when the maxima of interference falls to the minima of the diffraction? This will give you the missing order of the resultant pattern. Missing order. Okay, this is a very interesting thing. Suppose there is a point on the screen where the both condition for the interference maxima, which is in the order of n, that is a plus b sin theta is equal to plus minus n lambda, is satisfied at that point, as well as the diffraction produces there are minima of mth order, that is a sin theta is equal to plus minus m lambda, also valid at that point. So if those two equations are simultaneously valid, we can divide both of them. So you will get a plus b by a is equal to m by m. So n is equal to a plus b by a into m. So this interference order of, that is nth order of the interference pattern will be absent because it is superposed with 0. So the resultant will be some maximum value into 0, means again 0. So the interference maximum will be missing from the spectrum. That is why this is called missing order. Missing order means the resultant intensity is 0, instead of the fact that there is an interference maximum of nth order. So the order word comes from there, the order of interference, which is missing due to the superposition of the diffraction mean and the interference maxima, resulting in a mean, that is a minimum, that is a dark band there. So n is equal to a plus b by a into m is the condition for getting the nth maxima of interference pattern to be missing. So if you put a is equal to b, try some values. Let us take a is equal to b, that is the slit width is equal to the opaque space length, and then you will get n is equal to twice n, and you know n is equal to 1, 2, 3, so on, but not equal to 0. So n should be 2, 4, 6, 8. So even number of integers, that is the even number of interference maxima, will be absent from your spectra. And if you take b is equal to twice a, then you will get n is equal to 3m. So third, sixth, ninth third, sixth, ninth interference maxima will be absent from your spectra. Okay, so these are very valuable points, and let us take a look to the graphical representation. this is your interference pattern, which is cos square beta graph, and here the axis is beta axis is there. So this is your beta axis. Instead of theta, I am using the alpha and beta axis, but actually you are plotting the theta, because in beta there is sin theta and alpha there is sin theta, so they are in the same meaning, they have the same meaning while you plotting. So now the cos square beta curve is like this. At 0 the cos square beta is your maxima, and it is drawn just in scale. I have again forgotten to write the values of the beta and alpha there, because this is your pi by 2, this is again pi, this is 3 pi by 2, this is 2 pi, this is again the what will be this 5 pi by 2, this is 3 pi. So these are the points, and this is sin square alpha by alpha square. So if you take, see here at this point where beta is equal to what, pi, 2 pi, 3 pi, at the value of beta is equal to 3 pi and alpha is also 3 pi, there is a minima condition satisfied. Okay, so if the minima of the diffraction falls over this, because those two graphs are multiplied to each other, because in formula there is, see, the resultant intensity is 4I0, it is a constant, sin square alpha by alpha square into cos square beta. So multiply each coordinates of the two graphs to form the resultant graphs. So the resultant graph will be this envelope, but within this the interference pattern will be there. So this will act the envelope graph of this cos square beta curve. So it is in the proper scale, so you can understand the missing order has been formed at these points. Okay, I have forgotten to write the proper angles where, see you can understand from here there is 5 number of maxima within the first central max of the diffraction pattern, that is the first envelope. Okay, within this envelope you can find 5 orders, and this is the n is equal to 0th order of interference maxima. This is your n is equal to 1, this is n equal to 2, but n is equal to 3 is missing. So what should be the case? This is the case where you have assumed that b is equal to twice of a, that is the opaque space length is twice of the length of the slit width. So n is equal to 3m. So n is equal to 3, 6, 3rd, 6th, 9th order of the interference maxima will be absent from your spectra, and you can see from here the diffraction mean falls at the interference max at 3rd order, and the right hand side and also in the left hand side the 3rd order maxima of interference falls at the first mean of the diffraction pattern. So these patterns will be missing. So this is the resultant curve. The intensities are not evenly distributed, it is periodic, and at 0 angle the intensity is maximum, and then all the intensities are minimum. After some times intensity will rise, but the number of the maxima within the diffraction secondary maxima envelope will be smaller, so it is very hard to observe in your lab. So this will be observed clearly, but these patterns, these maxima are very hard to find in your laboratory. You can find it if you do this experiment. So at this point of time, let me stop and thank you for listening.